Hi, my name is Wonyoung Chang, and I'm a junior here at Utah State University.
And my name is Joe Pollock. I'm a senior here at Utah State University, and we created the Forarm and Hand for the InMoov open source robot for our Fall 2021 microcontroller hardware and software class.
So the system is powered by a microcontroller and two power banks, which are connected to the three buttons right here and to the 5 servo motors. The code allowed us to program 3 different gestures according to the 3 buttons. So we programmed to output the gesture to be rock, paper, or scissors according to the 3 red, yellow, and green buttons. The red button would output rock, yellow button would output paper, and the green button would output scissors. The string is connected from the servo motors to the fingers, so when the button is pressed, the rotation of the servo motors would result in the curl or straightening of the fingers.
This is the functionality of our InMoov Forarm and Hand. Here we have our 3 buttons, which are tied to an individual GPIO pin each. They use the sys-tick interrupt timers in order to identify when the button is pressed. The microcontroller also ties each individual characteristic of the project to a common ground. The power sources that we are using are 2 battery packs, which are 6 volts each. They both contain 4 AA batteries, and then also the microcontroller's 5-volt port. Now here is the InMoov Forarm and Hand. In the Forarm, we have 5 servo motors, which are also tied to individual GPIO pins. Those GPIO pins determine the PWM wave which is sent to each servo motor. They are also tied to that common ground. Each servo motor requires around 3 to 7.2 volts for power. As a result, we had to tie 2 servo motors per battery pack, and then the final servo motor is what is connected to the microcontroller. As the servo motors receive a PWM wave of around 1 millisecond, they will turn to 0 degrees. As you increase that, we eventually get to 90 degrees. The 0 degree rotation is what allows the hand to lay flat. Once the servo motors rotate to 90 degrees, the fist will curl. The black here represents the strings which are tied to each individual finger, which then is tied to each individual servo motor. There is a string on the back of each finger and on the front of each finger. As the servo motor rotates, the back will release and the front will pull, which is what creates the curl. The PWM waves that are created through the timer 2 of the microcontroller, and with a maximum waveform of 50 Hertz.
Gaël Langevin is a French sculptor and designer. He works for the biggest brand since more than 25 years. InMoov is a personal project. It was initiated in January 2012 as the first open source prosthetic hand. It has led to projects like Bionico, Enable, and many others. InMoov is the first open source 3D printed life-size robot, which is replicable on any home 3D printer with a 12 by 12 by 12 centimeter area. It is conceived as a development platform for universities, laboratories, hobbyists, but first of all for makers. Its concept, based on sharing and community, gives him the honor to be reproduced for countless projects throughout the world. Now with the idea and 3D printed parts of Gale, we were able to successfully create the InMoov hand and forearm. And this next video will show you our testing phase of this project. We set the servo motors to turn only 90 degrees in case unexpected results happen when we run the code. As you can see, when the green button is pressed, the hand gestures scissors. When the red button is pressed, it gestures rock. And when the yellow button is pressed, it gestures paper.
The lack of precision of the 3D printer prevented the holes from being created inside the finger, which resulted in us routing the string to the outside edge of the finger instead of inside. Additionally, the lack of precision of the 3D printer created a higher servo bed, so we cannot close the other part of the forearm.
Our final project proposal stated that we would use the InMoov forearm and hand, which would be 3D printed, and servos inside would be utilized in order to move the fingers inside of the hand. The servos would be operated by the microcontroller provided in the class, and the servos would change gestures based off of pressing our red, yellow, and green buttons, which were provided in our lab kit. The final project that we created matches all of these requirements, such as the red, yellow, and green button being utilized in code. Our servos operate each finger individually, and in addition, the microcontroller utilized in the class is also the microcontroller utilized for our final project. And now we will demonstrate our final product. I'll hit run on the code, and I've turned on each battery pack. And now we'll push each button to see which gesture it gives. There's scissors. There's our rock. And there's paper. This is our InMoov forearm and hand, and we've programmed it with our STM32 L476RG.